Good morning. I'm K.M. Amer Malik from IPEC8. My project proposes an autonomous drone system to deliver essential supplies to flood isolated communities in Bangladesh within a 15-kilometer range. This qualifies as a complex engineering problem because all seven characteristics are met. It requires deep knowledge across aerodynamics, embedded systems, and communication. It has conflict requirements, no standard solution, multiple stakeholders with opposing needs, and deeply interdependent subproblems. Problem statement and criteria. Bangladesh floods cut off communities for weeks. Boats and helicopters are slow, costly, and weather dependent. My objective is to design a drone that reaches victims within 15 kilometers, carries 5 kg of supplies, operates in adverse conditions, and costs what local agencies can actually afford. I defined seven success criteria: low cost, 5 kg payload, weather resistance, full autonomy, safe winch delivery, communication integration, and local repairability. Conflicting requirements and stakeholders. The key conflicts are low cost versus weather resistance, heavy payload versus long range, autonomous operation versus local repairability. My stakeholders are flood victims, DDM, NGOs, CAAB, and local technicians. All have different and often conflicting priorities. Existing solutions and Bangladesh context. Zipline cost $8,000 per unit, too expensive. UNICEF Malawi is still experimental. DJI Agras fails in monsoon conditions. Boats and helicopters are slow and costly. In Bangladesh, up to 70% of the country floods in extreme years. Communities are isolated for up to 3 weeks. Target districts are Sylhet, Sunamganj, Jamalpur, Chittagong, and Sirajganj, all within our 15-kilometer range. Drone type comparison. I evaluated three types. Fixed wing has great range but needs a runway. Impossible in a flood zone. Hybrid VTOL has no runway requirement but is too expensive and hard to repair locally. The multirotor needs no runway, carries sufficient payload, costs less, and is locally repairable. It advances to final selection. Delivery and communication option. For delivery, parachute drop is imprecise. Direct landing needs clear dry ground. The winch system is selected. It lowers the box precisely, works over rooftops, and medicine arrives intact. For communication, 4G fails when towers go down in flood. Satellite is too expensive. LORA radio is selected because it operates offline, covers 15 plus kilometer, and costs just $40 per module. Analyzing and selecting. After a 4-point analysis, functional, economic, safety, and environmental, the final selection is hexacopter plus winch plus LORA radio plus GPS waypoints at approximately $725 per unit. That's less than 10% of the cost of Zipline, fully CAAB compliant under 25 kg, electric powered with zero emissions and completely reusable. Prototype design. The prototype has three components: the hexacopter, six motors for redundancy, IP54 weatherproof, GPS with return to home failsafe, the payload box, 5 kg capacity, winch lowered, auto releases on ground contact, the ground control station, a laptop, and LoRa radio at the relief camp. The operator enters coordinates the drone flies autonomously, and every mission is logged. Now comes test plan. 5 tests must pass before field deployment. Load test, stable hover with 5 kg. Range test, full 15 km round trip on one charge. Weather test, stable at 40 km/h wind. Delivery test, box lands within 3 meters of target. Failure test, safe return to home if one motor fails. Documentation. The required deliveries include an engineering diagram of the full drone system, a Gantt chart for the 8-week timeline, a risk assessment covering motor failure, battery depletion, GPS loss, payload damage, and regulatory issues, and a detailed cost breakdown sheet. To summarize, I defined the problem with 7 criteria: benchmarked existing systems and mapped Bangladesh flood zone, evaluated 3 drone types, 3 delivery methods, and 3 communication systems, selected hexacopter plus winch plus LORA radio at 725 per unit, and designed the prototype with a 5 test validation plan. Thank you.